Hi, good day! Welcome in today's episode of ADEPA TV. I am Teacher Jay, your math buddy, and I will be here to help you in developing your logical reasoning and critical thinking skills. Are your learning activity sheets ready? What about your pen and paper? Great! Let's begin a fun and exciting lesson. For this lesson, you are expected to first define an arithmetic sequence and second, illustrate an arithmetic sequence. But before that, let's recall what sequence is all about. Sequence is an arrangement of objects, numbers, or even figures which follows a certain pattern. Also, you have learned about the processes in finding patterns of any sequence. Look at the following sequences. Can you see the specific pattern they follow? Let us try to give emphasis on the differences you observed while we undergo illustrating an arithmetic sequence. Again, look at the following sequences. What is the pattern you observed in each sequence? Let's start with sequence number 1, 2, 4, 6, 8, and so on. What is the pattern you observed? By adding 2 to the preceding term. The second sequence, 3, 6, 12, 24, and so on. What is the pattern you observed? By multiplying 2 to the preceding term. And the third sequence, 5, 10, 15, 20, and so on. What is the pattern you observed? By adding 5 to the preceding term. Now, try to observe the following sequences. Item number 1, 4, 7, 10, 13, and so on. Item number 2, 33, 38, 43, 48, and so on. Item number 3, negative 2, negative 6, negative 10, negative 14, and so on. Item number 4, 100, 98, 96, 94, and so on. Item number 5, 1/2, 1, 1 and 1/2, 2, and so on. Can you give the next two terms of the following sequences? If you get 16 and 19 in item 1, then you are correct. How did you get those terms? Notice that a constant number 3 is added to the preceding term to get the next term. In item 2, the two terms are 53 and 58. How? Because 5 is added to the preceding term to get the next term. In item 3, negative 4 is added to the preceding term. Then, what are the next two terms? Yes, these are negative 18 and negative 22. In item number 4, 92 and 90 are the next two terms because negative 2 is added to the preceding term. And in item number 5, 1/2 is added to the preceding term to get 2 1/2 and 3 as the next two terms. Notice that a constant or a common number is added to the preceding term or the next number before it to get the next term in each of the sequences. The constant number being added is called the common difference and is represented by the letter D. All these sequences are called arithmetic sequences. To find the common difference, D, you can simply subtract the second term, or a sub 2, by the first term, or a sub 1. That's a sub 2 minus a sub 1, or the third term, or a sub 3, by the second term, or a sub 2. That's a sub 3 minus a sub 2, or a sub 4, the fourth term, by the third term, or a sub 3. That's a sub 4 minus a sub 3. Or, in general, a term, or a sub n, by its preceding term, that's a sub n minus 1. The common difference is equal to a sub n minus a sub n minus 1. So what exactly arithmetic sequences are? A sequence in which term after the first is formed by adding a fixed number to the preceding term is called arithmetic sequence. Again, a sequence in which term after the first is formed by adding a fixed number to the preceding term is called arithmetic sequence. And the fixed number or constant is called the common difference, denoted by the letter D. Again, the fixed number or constant is called the common difference, denoted by the letter D. Is arithmetic sequence more clear this time? Great! Let's move to the first activity. From the discussion on arithmetic sequence, solve the problems that follow. Determine if the sequence is arithmetic or not. If it is, find the common difference and the next three terms of the sequence. For the first item, -4, 3, 10, 17. Is this an arithmetic sequence? Yes or no? To find out if the sequence is arithmetic, there must be a common difference between any two consecutive terms in the sequence. For the first example, let's get the difference between the second term and the first term. That's a sub 2 minus a sub 1. Our second term, which is 3, minus our first term, which is -4, that's equal to 7. Now let's try for the third term minus the second term. That's a sub 3 minus a sub 2. Our third term, which is 10, minus the second term, which is 3. Their difference is still 7. And the fourth term minus the third term. That's a sub 4 minus a sub 3. Our fourth term is 17 minus our third term, which is 10. Their difference is 7. Because there is a common difference between consecutive terms, the sequence is arithmetic. The next three terms are obtained by adding 7 to the preceding term. So that's a sub 5 is equal to a sub 4 plus 7. So that's 17 plus 7. The fifth term will be now equal to 24. What do you think the sixth and seventh term will be? Go ahead and make it a try. I'll give you 10 seconds. Our a sub 6, or the sixth term, will be equal to a sub 5 plus 7. Our fifth term, which is 24, plus 7, the sixth term, will now equal to 31. The seventh term, or a sub 7, is equal to the sum of a sub 6 plus 7. Our sixth term, which is 31, plus 7, the seventh term, will now be equal to 38. So the next three terms of this sequence are 24, 31, and 38. Fantastic! Let's move on to the second example. Write the first 5 terms of the arithmetic sequence with 5 as the first term and with a common difference of -2. So that's a sub 2 is equal to the sum of a sub 1 plus the common difference, which is -2. Moving on, we have a sub 2 is equal to the first term, which is 5, plus -2. Our second term is equal to +3. For the third term, that's a sub 3 is equal to a sub 2 plus the common difference of -2. Our a sub 2, which is 3 plus -2, our third term will be equal to +1. The fourth term is equal to the sum of the third term and the second term. That's a sub 4 is equal to a sub 3 plus the common difference, which is -2. A sub 3 is 1 plus -2. Our fourth term is equal to -1. For the fifth term, we will get the sum of the fourth term and the common difference of -2. So that's a sub 5 is equal to a sub 4 plus the common difference of -2. Our a sub 4, which is -1, plus -2, our fifth term is equal to -3. As you notice, we add the common difference or the constant to the preceding term to get the next term. So the first 5 terms of the sequence are 5, 3, 1, -1, and -3. You're doing a great job. Amazing! Now, let's proceed to the fourth example. Find the common difference of the arithmetic sequence 3a minus 1, 3a, 3a plus 1, and so on. Let's take it one by one. We must remember that in an arithmetic sequence, the common difference, d, is a term minus the preceding term. Thus, the difference is equal to a sub 2 minus a sub 1. Again, we will use this as our equation 1. Or, we can also use d is equal to the difference of a sub 3 minus a sub 2. This will be our equation 2. If we use equation 1 and substitute the given, we will have, for equation 1, that's a sub 2, which is 3a, minus the first term, or a sub 1, that is 3a minus 1. So, what do you think is the common difference? Let's solve. You have d is equal to 3a minus 3a minus 1. Remember, when we subtract these two terms, we're going to change the sign of their subtrahend to its opposite, which will become positive. This will become negative. Then we will proceed to addition rules. Since these two numbers are opposite in sign, we will subtract 3a plus negative 3a is 0. We will have 1. You are right. The common difference is 1. What if we use the second equation? Would we arrive at the same answer? Let's try. For equation 2, that is the difference of a sub 3, which is 3a plus 1, minus the second term, which is 3a. Next, let's have 3a plus 1 minus 3a. Again, the sign of our subtrahend will change into its opposite, so the 3a will become negative, and we will proceed to addition rules. Again, subtract the coefficients for this part, so that's positive 3 plus negative 3 will be 0. What's left is 1. See? Regardless of the equation we used, we will arrive with the same common difference. Nice try! Let me have this set of questions for you. This will further measure your understanding of today's lesson. What is an arithmetic sequence? Next, how do we get the next terms of an arithmetic sequence? Did you know that arithmetic sequence can be applied to real-life situations? Take a look at this. Arithmetic sequence can be observed around us, like the following fare rate for the first 4 kilometers of a modernized PUJ under General Community Quarantine released by LTFRB last April 24, 2020. For the first kilometer, you have to pay 11 pesos. For the second kilometer, you have to pay 12 pesos and 50 centavos. For the third kilometer, you have to pay 14 pesos. And for the fourth kilometer, you have to pay 15 pesos and 50 centavos. If we compute the increase of fare for every increase of kilometer distance, they are all equivalent to 1 peso and 50 centavos. With this, The fare rate is an example of an arithmetic sequence. How much will you pay if you are going to travel for 10 kilometers? You are going to pay 24 pesos and 50 centavos. Aside from examples involving fare or money, can you give another situation that best illustrate an arithmetic sequence? Great job! Thanks for sharing your thoughts and ideas for this lesson. Congratulations for doing your best. And that concludes our lesson for today. See you again in the next episode. I am Teacher Jay also. Please bear in mind that learning math is fun and easy. Be also, be awesome. Only here on Ep2 TV.